Let's take a look at what conic sections are. Conic sections are curves that are formed by the intersection of a plane and a cone. A cone is exactly how you imagine it to be, like an ice cream cone, but in mathematics, a cone is something of this type, where you can imagine two ice cream cones on top of each other connected to that point. So if you take different cross sections of this, you end up with something called conic sections. You might be familiar with some of the conic sections. Take a look. If you take the cone and you slice it horizontally, you will see a circle. If you tilt the plane a little bit at an angle, you end up with ellipses. If you keep tilting it, you'll see you end up with parabolas and then something called hyperbolas. So hyperbolas, parabolas, ellipses, and circles. Those are what we refer to as conic sections. So here's in detail how they might look in case you had trouble visualizing it before. And the hyperbola is gotten by taking the cut parallel to the axis of the cone. So you can see part of it is here and part of it is here. That's why I thought this might be a better picture, because here you only see one part of it. All the other ones, there's only one part because of how the plane was tilted. So another way people think of conic sections is a geometric definition. This might be hard for you to understand, but we'll take an example and then that might make it clear. So in this way, a conic section is really the locus of all points P. Locus just means all the points P that satisfy the following condition: that its distance from a fixed point called focus in the plane has a constant ratio to the distance from a fixed straight line called the directrix. So if this ratio is 1, for example, you get parabolas. If the distance is smaller than 1, you get ellipses, and bigger than 1, you'll get hyperbolas. But it's a hard definition to process, so let's take a look at what this really means. So here's a fixed line, which we're going to call the directrix. Here's a fixed point called the focus. So if you look at the perpendicular drop from this focus to the directrix, the point that's exactly halfway between is a point that is exactly the same distance from the directrix as it is from the focus. Such a point is referred to as the vertex. So we're going to call this point vertex. How about you think this is the only point that will satisfy that condition? The answer is no, because let's take a look at this point here and move it. So for example, if you drop a perpendicular from that point to that point, this is the distance of this point from the directrix. And then if you connect this point to the focus, that's the distance of the point from the focus. So here's the point. So all of these points that we have here are points that are exactly identically equal from the directrix as they are from the focus. And so this generates a parabola, and then interesting things happen, properties happen when you look at the focus and the directrix. So here's another way people visualize conic sections, and when the distance ratio from here to here is equal, you have parabolas. All right, so let's take a look at parabolas then. Parabola is a collection of all points that are equidistant from a fixed point called focus and a fixed line called the directrix. So let's take a look at how equations of parabolas might look like. You're already familiar when we were doing transformations of y minus k equals a times parentheses x minus h squared. So now we're writing the equation in a different format. We have the square term equals 4 times a number y minus k. If you write your equation in this form, you will get hk as your vertex, and the focus, because it's a parabola either going up or down, it's the y coordinate, that will change from the vertex. The P is the distance between the vertex and the focus. So you're going P up from HK or down depending on which way your parabola opens up. So if P is greater than 0, parabola will open up. P is less than 0, parabola will open down. We'll take examples so that it'll become clear what we're talking about. Similarly, if we write y minus k bracket squared equals 4p times x minus h, again hk is our vertex, and this time it's a sideways parabolas, and so h plus p comma k will give you the focus. And again, if p is greater than 0, the parabola opens to the right, and negative p will give you parabola opens to the left. All right, let's take an example then and take a look at all the different parts of a parabola from this equation that we have. So x minus 2 squared equals 8 times y plus 3. This is already in the right format, so we can extract our vertex. X coordinate for the vertex will be 2, and y coordinate for the vertex will be negative 3. So we have that our vertex is 2, negative 3. 2, negative 3. This number here, 8, is our 4p. So 4p is 8, which gives us p is 2. So it's a parabola opening up because p is positive, and the focus is 2 up from the vertex. So 2 up from here, negative 3 plus 2 will give you negative 1. So 2, negative 1 is our focus, and the directrix will be 2 down from the vertex. So 1, 2, which will make it negative 5. So y equals negative 5 is our directrix, and this is our focus. Something very interesting happens in conic sections. We can look at something called the reflective property of conic sections. For parabolas, this is what it means. If this parabola was made of a reflective surface, like a mirror or satellite dish, so you can see how parabolic mirrors, parabolic satellite dishes, you see parabolas in many different forms. What you actually see, a three-dimensional version of parabolas, which are called paraboloids. Anyway, the reflective property is the following. If you have light rays or energies coming towards this reflective surface, no matter where they hit, they will all bounce back right to the focus. So the reflective property is if you have rays coming in parallel like this to each other, they will bounce back to the focus, which means a distant star can give you a very sharp image right here. Or a satellite that's collecting all these digital signals, this will be the receiver of the satellite. On the other hand, if a light source originates at the focus, then it will bounce back towards these points and then up. And so a small source of energy can produce a large beam, like in searchlights. So really interesting properties happen when you look at the focus and the reflective surface. That's a parabola. Let's take a look at what happens to the coefficient of x squared terms and how it affects the shape of the parabola. So if you look at y equals x squared, which is this black graph here, then the blue graph is the graph of y equals negative 4x squared. So y equals negative 4x squared is, first of all, because of negative upside down, and the 4 is making it narrower. Let's change the 4 to a 2 and see what the effect is. So it became a little wider. Let's make it negative 1.1. And I've made it wider. So the larger our coefficient gets, the graph will become wider and wider. What happens if you make it very close to 0? You can see it's even wider. So closer to 0 the coefficient is, the wider the graph is. Same thing will happen on the positive side. You can see a positive 0.1 is making the graph wider, but if you make it 4, you will get narrower graph. And so one thing to remember is that if your absolute value of the coefficient is bigger than 1, you have a narrower graph. If your coefficient absolute value is closer to 0, so between 0 and 1, then you will have a wider graph. A positive coefficient of x squared makes the parabola face up, and negative will make it face down. All right, so let's put it all together and take a look at what it really means then. If you have the equation of the parabola written in this form, a parentheses x minus h squared plus k, which is what we've been used to when we were doing transformation, is called the equation of parabola in standard form. hk is your vertex. A determines the direction of the parabola up, down, but it also contributes to the width of the parabola. So let's just review quickly what we've seen. If A is bigger than 0, parabola opens up. Here's hk, which is your vertex. If A is less than 0, parabola faces down. If your absolute value of A is bigger than 1, you have narrower parabolas. And if your A is between 0 and 1, then you have wider parabolas. Similarly, if you were writing the equation in standard form as x equals a parentheses y minus k squared plus h, then again hk is our vertex. A determines the direction and also contributes to the width of the parabola, except this time the parabola opens to the right if a is positive and to the left if a is negative. And then the parabola is narrower if you have the absolute value bigger than 1, and wider if absolute value is smaller than 1. So it's consistent with the previous observations. So again, positive A means it opens to the right, negative A means opens to the left. Absolute value bigger than 1 is narrower graphs, and absolute value between 0 and 1, you have wider graphs. So if I ask you, sketch the graph of this parabola, how would you continue? Well, we know that our A is 5, so we know it's a parabola facing upwards and it's a narrow parabola. But how do we find the vertex? You have to get it in the standard form in order to find the vertex. So, do you remember how to do that? We will have to use a process called completing the squares. If you don't recall that process, let's just do this example together. So take the 2 and subtract so that it will be on the other side. From these two terms, pull the 5 out. So when you factor a 5 out, remember, 5 times x squared is 5x squared. 5 times 3/5 will give you the 3x. And then completing the square process is add half of the middle term coefficient, which is the 3/5 squared, to complete the square. And so 3/5 is your coefficient, and half of that 3/5 is going to be this number here, add its square. Now remember, what you are really adding is 5 times 3 over 2 times 5 squared. So we have to add the same number on the other side to preserve the equation. So let's simplify a little bit here, and you get 9/20 here. And this, the whole reason we did that is to complete squares. So this will become 3 over 10. So this will be x plus 3/10 bracket squared. And these two numbers will add up to 31 over 20. And that gives us our vertex. Our vertex is negative 3/10. And 2 minus 9/20, which is really 31/20, will end up with our vertex. So we have our vertex, but in order to sketch the graph of this parabola, we're going to have 2 other points. So 3 points determine a parabola uniquely. So make a table. So if I plug in x equals negative 3/10, 31/20 is our vertex. When x is 0, put 0 in for x here, you end up with 2. That's our y coordinate. So that's 3/10 away. If I go 3/10 the other way, I should get the same coordinate because you have symmetry in parabolas. So here's the graph where we plotted these points. So here's the point 0, 2. Here's the point -6/10 and 2. And here's the point -3/10 and 31/20, which is our vertex. In ALX, when you graph these, you will have coordinates to plot, and there's a tool where you can enter these coordinates. You don't have to plot necessarily these points. You just need a vertex, one point to the left of it, one point to the right of it, and that will give you the graph. So in general then, if you do this completing the square process to a generic quadratic equation, so if you have y equals ax squared plus bx plus c, where a is non-zero, and you complete squares, you will get the equation in the form we saw before. So let's do completing the squares here. So we took the number c and dumped it to the other side. We took half of b over a and you squared it. So that's what we're going to do. Multiply it out. This is what you got. And so our vertex is x coordinate is minus b over 2a, and our y coordinate is c minus b squared over 4a. So I think that in terms of remembering the formula, I would only remember the x coordinate, which is given by minus b over 2a. Plug that coordinate into the original equation for x to get the y coordinate instead of memorizing this formula. And you actually can just complete squares all the time. So even if you forgot formula, you have a way out. That's the beauty of mathematics. If you know what you're doing, you can get the vertex very easily.